Thank you very much. Please, always a pleasure to be with all of you. Seeing so many people in this hall. Some of you might have heard pieces of this talk. This is my definition of diabetes that I think we need to start thinking about. That metabolic dysfunction, obesity, and diabetes are the consequence of an inability to optimize energy processing, storage, and utilization. The way to think about it is that the reason that glucose goes up in the blood is simply because we are not able to metabolize it, right? So if you think about it, diabetes is actually a disease of fuel crisis. What we need to understand is that our body is built for scarcity. It has adapted for scarcity for millions of years. From evolution, it has adapted for scarcity. Therefore, when someone who doesn't have money, what will he do? When he sees anything, he will hoard it. Right? Similarly, we need the right amount, the right kind, and the right time. And clearly what happens is, if there is excess amount of food, it is stored. Right? Normally, and I don't want to go into this because I do many talks on my gut microbiome. Remember that while we think that our body is ours, a trillion bacteria also think this body is theirs. We are actually, living in a commensalic, symbiotic relationship with bacteria. In fact, there are many of our nutrients that we cannot even process. Our internal processes don't work. These nutrients need to be processed, for example, bile acids or others need to be processed by the microbiome for it to work, right? So it has to be processed and controlled. So which means, and as I keep telling you, that there are two gifts that your mother has given you, her mitochondria, and the second, her microbiome. These are maternally inherited. Remember, there are no mitochondrial DNA in the sperm. So which means, except 4 families in the entire world in the last 50 years, all of us depend on our Shakti from our mother only. That is why she is Shakti. So the mitochondrial DNA is inherited, the microbiome is inherited. The microbiome is inherited over generations. Therefore, if you are somebody who eats pappu annam and tachi mamam, then that's really what your mother has eaten, her mother has eaten, her mother has eaten. And if you add biryani to it and pizza to it, your microbiome are not familiar to it. It's very simple. It's unfamiliar to the microbiome, the second part. The third thing is that eating is controlled by the kind of enzymes that are exhibited at the time that they need to be exhibited. I'll show you data on that. That is, processing is partitioned. When food is available, glucose is processed. When food is not available, fat is processed. So when you provide glucose when fat is going to be processed, then your processing system will have a problem. This is all. If you bring it down, diabetes, into why diabetes is happening, it is because the right amount of food is not given, the right kind of food is not given, and the food is not given at the right time. Okay? So this overwhelms processing. When it overwhelms processing, and then it overwhelms the storage also. If the storage is overwhelmed, the fat becomes ectopic. If the processing is overcome, the cell becomes dysfunctional. Both of these lead to metabolic dysfunction, and therefore they lead to systemic and organ dysfunction. I'm still in the process of writing this, but I think this is a simple way to understand what goes wrong. Right? So that brings it to which is the processing unit in the cell? It's a mitochondria. Ultimately, what happens is that because of this respiratory cycle chain, the hydrogen ion moves into the membrane, then there is a leak, and when that leak, that provides converts ATP to ADP, and this is how fuel works. Everything is a TCA cycle that drives it. Now, when you have mitochondrial dysfunction, many things happen. One is, in fact, we keep looking at genetic changes in diabetes, right? The most number of genetic changes occur in the mitochondrial tDNA because it is the closest to the mitochondrial processes. But the way the mitochondria works is, when you have plenty of food, it divides, right? It's and gets rid of the problem areas. This is called mitophagy. On the other hand, when you are starving, it coalesces. This coalescing and division cycle is what keeps the mitochondria efficient. So what happens is, bits of the mitochondria are packed away. And in fact, these become endoliposomes, and they actually communicate to other cells and tell them that something is going wrong. This particular cell is eating too much, it is getting into disarray, it is in trouble. So this is going on. But normally, the mitochondria can repair itself. This is called the unfold protein reaction. It can repair itself. But everything is only to a small. See, your wife will tolerate you going to the bar with your friends. Maybe if you go once a month. If you do it every day, what will she do? She will come with a stick outside, which is exactly what is happening, right? So the mitochondrial dysfunction, normally what occurs with age is that this slows down. What happens in diabetes? It is accelerated much earlier. I told you about the second part, which is this is something that we want to understand, that food and light are connected. For example, in plants, food is glucose, photosynthesis, and then at night there's repair. Humans, daytime food is processed, nighttime you rest and you sleep and you repair. In fact, the elegant studies on sleep, I've talked about it before, I won't do it today. Now in wolves and rats it is reversed, right? But food and light are together. What have we done? We have shortened light, we have increased food. And therefore, what happens is the partitioning of food. For example, pyruvate and glucose get into the TCA, glucose gets into the pyruvate in the TCA cycle. Fatty acyl coenzyme comes with acetyl coenzyme A. And therefore, the enzymes that process it are also circadianly controlled. Now, when you change the cycle and you eat at 10:30 at night and 11:30 at night, like these guys did yesterday night, alright? Basically, what you're doing is overwhelming the processing power of the mitochondria. Nee paaditrunda. Right? So that's really what is happening. And what is important to understand is that energy production, glucose-stimulated insulin secretion are dependent on the circadian rhythm. In fact, the BMAL clock gene. Why is it important? Because this particular protein is uncoupling protein, which allows ATP to be produced, is what powers glucose-stimulated insulin secretion. Now, let's go back and say, what did I say? That diabetes is a condition where the body is not able to process energy. Where is that energy processed? In the mitochondria. Therefore, diabetes is a disease of mitochondrial dysfunction. Simple. Right? And why do some people get it? Why some people don't get it? Because the mitochondrial capacity is altered. So the mitochondria, if it has an ability to compensate for some amount of eating in woodlands. But eating 3 times a day in Buharis, it cannot concentrate. Right? It can cause insulin dysfunction, it can cause beta cell dysfunction. All of these because it's happening in the mitochondria. So, because there is dysfunction in the mitochondria, the inability to process it, there is a lowering of the ATP production, the amount of energy that is available is reduced, you get this endoplasmic reticular stress, everything else is just a follow-up. All the things that everybody tells you, diabetes is a disease of oxidative distress, endoplasmic reticular stress, all of that starts because the mitochondria are not functioning properly. So, can you target it? Absolutely. One, the simplest way to target is to reduce the preload. Eat less, eat on time, and eat what your mother, not to be misogynistic, what your mother or your wife cooks for you. Because they also serve it, because they are the ones who have passed it over generations, and they serve it with love and affection for you. The Kanchi seer would say the reason that mother's food is fantastic is because she will wake up in the morning, she will take a bath, and while she's cooking, she'll be saying slokas, and she will power that food for you. It's a good thought, but today nobody even takes a bath before they cook. Right? But to go back, can you target it? There are some very, very new proteins that are coming up that will target mitochondria. And just for you to know that Pioglitazone, that the drug that we all talk about, we know that while we know it works at PPAR gamma, the most important work that it does is it slows down the entry of pyruvate into the TCA cycle. And in fact, the newer drugs of or TCDs that are coming are purely working on it. So one of the things that we don't know that we've already been using for many years is pioglitazone, which is a mitochondrial modulator. These other drugs are going to take a little longer to come. The S3, the Dinosaur, the OPA1, all of these, that will take a while to come. But in the meantime, somewhere around, one drug snuck in, and that is imiglimin. A first-in-class glimin molecule, because it works on mitochondria, and I'll show you how it does, it reduces insulin resistance as well as improves beta cell dysfunction. The simple way to think about it is, you see metformin. If metformin wears a cap, it becomes imiglimin. That CH3N-NH molecule on top is all that. It's a triazine molecule. It's a bicoinite. 1000 milligram BID. Even the SR is only 1000 BID. It is not 1000 OD. It's not metabolized. No drug interactions are known. Use 1000 BID if the EGFR is more than this thing. Metformin, you have to stop at EGFR of 30. This you don't. You can go up to 15. No dose adjustment in hepatic impairment. And very safe. How does it work? Metformin works at this particular thing. It causes a reversible inhibition of cycle 1. But imiglimin does something very interesting. It bypasses the respiratory chain and moves the hydrogen ion to chain 3. Therefore, it makes the respiratory cycle more efficient. Okay. The second thing it does is, it alters the fuel at 1, something that metformin does, but imiglimin does it reversibly, metformin does it irreversibly. That's really why metformin should not be used in mitochondrial diabetes. We have no data on imiglimin in mitochondrial diabetes, but hereditary mitochondrial diabetes, metformin is a contraindication because it works at respiratory chain 1. Third, it works something by reducing this particular pore called the permeability transition pore. What happens is when there is buildup of toxins, these go through these pores and communicate to the other cells and cause dysfunction in the other cells also. That is reduced with imiglimin, right? Unfortunately, we are never going to get great studies on imiglimin because the people who developed it abandoned it and went away. It is being raised, it's an orphan being raised by Indian pharmaceutical companies. But having said that, reasonably works well. In patients who are metformin intolerant, it works even better. Brings down the A1C by 0.5 to 0.8. Remarkably well tolerated, even with GLP-1 RA. I don't believe that metformin is a Sri Ganesha of diabetes. I don't use it anymore. My first drug is a GLP-1 RA and SGLT2 inhibitors. If I need a second drug, I've started using imiglimin a lot. This is the Indian data. This is the A1C. This is the combination data. All of this, I'm sure you understand. But the reason that this talk, and I'm happy that Torrent doesn't push me to use their own slides and all of that. They're very, very happy when I push mitochondria as a target. But I have a lot of good experience with imiglimin. We've had some publications on this. But the idea is to understand that the mitochondria is a good target for diabetes. And these are good adjunct therapies. So the story of diabetes is a story of altered fuel metabolism. The mitochondria are the key to understanding fuel energetics. Mitochondrial dysfunction is the proximate cause of cellular and organic dysfunction. Targeting mitochondrial dysfunction is a promising therapeutic strategy, and imiglimin is only the first of these strategies, and the next few years we will see a few more coming. When the buzz of the GLPs die away, or they continue to move in a different tangent, you will find these drugs, 2 drugs that will come out, the newer pioglitazone congeners which are mitochondrial active, and then the next set of mitochondrial drugs that will come. Thank you for your patience. Thank you so much.
Thank you, sir. That was a very fascinating tour into